is a percentile. This is actually really important. So a percentile is a number from 0 to 100 that you can associate with the value x from a data set. It shows the percent of data that are less than or equal to x. So I'm going to highlight that. So a percentile represents the percent of data that are less than or equal to that amount. So if x, so for example, if x is at the 63rd percentile, then what that means is that 63% of the data are less than or equal to x. So some of you, if you, I'm sure you've heard, like I hear it on TV a lot because we don't really take SATs and stuff, but if you're going to medical school or something, sometimes you have to take, and you have to take the MCAT. But for example, the other day I was watching 21. Have you ever seen 21? Okay, well it's a show about these people that go count cards in Vegas. Anyways, so he's really, really smart. It's a really good show. You should see it. So there's this kid, and he's really smart, and he's bragging about himself, and he says, I even scored in the 95th percentile on the MCAT. So what that means is he scored 95% high. I mean, he was in the 95th percentile, so that means 95% of people that take the test are below him. Does that make sense? So he's not extremely high. Does that kind of make sense? Yeah. So he was in the 95th percentile, so 95% of people are at or below what he scored, so he's way up there. Anyways, so this is how let's just practice that. So here's an ordered list of midterm test scores for a Spanish class. What value is at the 65th percentile? Now it has nothing to do with these particular numbers. So let's look here. This is in order from least to greatest. Awesome. You do need your data in order from least to greatest. So let's first figure out 65% of this data. So how many data points do we have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So does everybody understand we have a total of 20 scores here? Sweet. So we want to know, it says what is the value at the 65th percentile? So what is 65% of 20? So you'll take 20 and you'll multiply it by 0.65. Go, tell me, how many values is that? 13 values, okay? So I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there, that is the value at the 65th percentile because 65% of the data is at or below that value. Does everybody understand that? So this person that got an 82, they drew at the 65th percentile, so 65% of the class scored at or below him. Does that make sense, everybody? So it just depends on the wording. So it says, what is the value at the 65th percentile? It's 82. Now, if it said what values fall below, or like what values are at the 65th percentile, values would be all of these, right? Yeah. At or below. So this is our 65th percentile, but any value at or below that would be all within the 65th percentile. Does everybody understand that? Sweet. So let's look at this one. Here's an ordered list of midterm test scores, once again, in a Spanish class. What values at the 55th percentile? So once again, we need to know the total real quick. So if we count this up, it's 20 again. So 55%. This one's the 55th percentile. So what value? So how many values is that? 11. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right there. So 55% of the data is at or below 79. Is everybody comfortable with that? Okay, so then it says, what's the value of the 95th? How many values? 19. So that would be right here, right? So 95% of the data is at or below that. Sweet. What if it's worded like this? So this is different, and then I'm going to let you go. So it's given these values here. Now they're in order from least to greatest. Once again, I can't stress enough when you're finding percentile to have it in from least to greatest. So right here it is. It says, at what percentile is 1? So first of all, we got to know how many total here. So let's figure out the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? Again? So we have a total of 20 values. So it says, at what percentile is 1? So doesn't 1 happen 1, 2, 3, 4, 5, 6? 6 out of how many? 20. So it happens 6 out of 20. So it's at the 6th point out of 20, because this is the furthest one. So what do we get here? 30. 30? So 30th percentile. 30%. Is that what you got? 0.30? So that's 30th percentile. Does everybody see? 30% of the data is at or below that one. Okay, sweet. So now it says, at what percentile is 34? So from least to greatest, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Does everybody understand that there's 13? It's at 13 out of 20. So what percentile is that? 65. So it's at the 65th percentile. Because that's saying 65% of the data is at or below that 34. Are we all good with how percentile works? Okay, awesome. Finish the worksheet from last time. I'll give you a couple minutes. Percentile is pretty quick. And then we'll move on to today's. Okay, so remember, statistics is the analyzing and comparing sets of data. We can analyze the data by looking at measures of central tendencies. That's what we did yesterday. So we looked at mean, median, mode, range, and interquartile range. Mean means average. If I say you're an average student, that's kind of mean. Remember, that kind of helps me remember what mean is. Mode means it happens the most. What happens the most? And you can't have a bimodal set of data. So if you have two modes, it's bimodal. Anything, if you have more than two modes, then the modes statistically aren't significant, so we just say no mode. Or we would just say too many modes, not significant. Median is the middle, the actual middle. So you have to have your data in order from least to greatest. You find the middle of the values, and that would be Q2, which means quartile 2. Then you can find the median of the lower half and the upper half, which would be Q1 and Q3, and that would give us our interquartile range, Q3 minus Q1. And then the range is the high minus the low, right, everybody? The highest value minus the lowest. Okay, so today we're doing 9-2. We're going to be dealing with standard deviation. So range. Range is a measure of, this is what we saw yesterday. So range is a measure of variation, which describes how the data is spread out. If it's ranging between 1 inch to 6 inch, then isn't that a range of 5 inches? Does everybody understand? Okay, so once again, range describes how the data is spread out. It's spread amongst 5 inches, 1 to 6. Does everybody understand that? So standard deviation and variance is similar. It's going to describe spread. So standard deviation and variance is the measure of how far the number in the data sets deviate from the mean. So once again, standard deviation and variance both mean how far the numbers deviate from the mean, where the mean is the average. Okay? So for example, we won't get to the example yet. Let's just talk about some notation. So standard deviation is written as a sigma. Sigma is a Greek symbol. So this sigma is like this O with a little tail at the top. And then variance is written as, it is sigma squared. So if our standard deviation was 2, our variance would be 4, because 2 squared is 4. Does everybody understand? So sigma squared is variance. Standard deviation is sigma. So, I think I skipped. No. So find the mean, variance, and standard deviation for the data set. There are formulas, but this isn't honors, so I'm not going to make you go through the formula. I do need you to understand there are formulas to find this, though. If you take a college-level statistics course, which many of you will, they will make you go through and do it by hand. It's not that hard. It's plug and chug, but we know how to do it with a calculator will do it for you, so in regular, if you can do it, it doesn't matter how. So, everybody, we're going to find the mean, the variance, and standard deviation for this data set. So your calculator is going to do it for you. Now, you don't know how we apply standard deviation or variance yet. We're going to get there. Right now, we're just worried about finding them. So your calculator will do it for you. So everybody start typing this in. Go to Stat, into Edit, and in List 1, type in these values. I'm doing number 2 off the worksheet for today, so it's helping you out. So we're doing number 2 off the worksheet. So we're going to find the mean, which means average. We're going to find the variance and standard deviation for the data set. Your calculator will do it for you. So once again, go Stat, into List 1, type in those values from Problem 2 on the worksheet. Well, you shouldn't be able... Wait, what are you talking about? We're just typing these into our calculators right now. Oh, you already typed in the one variable stats. Okay. So now now if you want the statistics, you go to stat, hit the stat key again. Instead of going into edit, go over to calculate. So you'll scroll over with your arrows. Is everybody following me? Then calculate. You're going to calculate the one variable statistics. We're just talking one variable here. There's not two things going on. One thing's going on. So you'll calculate your one variable statistics. So this is what you should have on your screen. So stat, and I already have mine typed in. So you're going over to stat, over to calculate your one variable statistics. And it's doing it of list 1. So it's going to give you X bar, which means the mean. Remember we learned that yesterday. X bar means mean. So we know our average is 66.1. So in the future, if you don't want to have to figure out the mean yourself, you could type it in, do your one variable statistics. So you know your mean is 66.1. And then if you look right here, do you see sigma? Do you see sigma of X?
We didn't get that.
What do you mean you didn't get that?
Like we didn't get 60, 17, 30, 40.
I got 28.1.
Did you make sure you typed in these values?
Yeah,
You're short. You didn't type in 2, did you?
nope.
You typed in every single one of those values. How is that possible?
What did you get?
30.3. I got 30.3 too.
What you got? I was doing wrong problem. I was doing number 7.
Oh.
This is all making sense now. Okay, so let's go with what you guys got since you typed in the right values. What's X bar? 30? Let's round to 1 decimal. 30?
30.
30. 30? Okay, so 30. 30.3? Okay, sweet. And then, so our mean, our average is 30.3. What's our standard deviation? Find sigma, go.
3.2.
3.2, are we all good with what sigma is? On your calculator, is sigma 3.2?
Yeah.
What's the full decimal?
3.24.
3.2, the full decimal. 3.24?
3.1448.
Okay, so I can't hear you. You just said that way too fast.
Oh.
3.24, 89, 31,
448.
448.
Yeah.
That's everything, right? Okay, so now we've got to find, your calculator won't give you sigma squared. So we've got to type into our calculator that full decimal squared. You have to type in the full decimal squared. So go, get out of the one variable statistics and just type in 3.248931,448 squared.
10.5.
So now we can round 10.5? Yep. 10.5. Sweet. What was after 5? It was 5.5. So then, guys, that would round to be 10.6, right? Okay, so 10.6, and now we can go back and round sigma. Let's just go with 3.2. Does everybody understand? But the reason I had to put in the full decimal is to find the correct square. With no rounding error, I had to type in the full decimal. So are you guys good with finding the mean, standard deviation, and variance? Okay, then do these problems quickly. Go, 5 through 6.
Wait, I have a question about
You're doing 1 through 6. So, this is how you apply standard deviations. So once again, standard deviations is how far the data deviates from the mean. So every value in a data list falls within a certain number of standard deviations of the mean. So once again, every value in a data list falls within a certain number of standard deviations of the mean. So for example here, let's say our mean of some data set was 50 and the standard deviation is 10. Then values 40 and 60 fall within one standard deviation of the mean. If our mean is 50 and we're talking a standard deviation 10, then 10 above and below would be within one standard deviation, right? So values between 40 and 60. Now I'll write that up here. So once again, our mean is the average, and then our standard deviation is 10. So one below and one above would be a standard distance from the mean. So that would be 10, right? So that puts us at 60 and 40. So values between that would fall within one standard deviation from the mean. Does everybody understand that? So then values between 30 and 70, so if we go one more standard deviation, that would be 2 standard deviations, so that's 10 more. That would be at 30. And one more standard deviation, that's 2 standard deviations away from the mean. So that would put us at 70. So values between 30 to 70 fall within 2 standard deviations of the mean. Does everybody understand that? Okay. Sweet. So number 7, it says, determine the whole number of standard deviation that includes all the data values. So we know all these data values will fall within a certain number of standard deviations from the mean. So, number 7, we are actually given on number 7, it says, the hours in your study groups study 66.1, the standard deviation is 2.9, so it gives us the average and it gives us 2.9. But let me just show you how to do it on your calculator. I mean, you know how to do it on your calculator, right? So we pull up our calculator. Once again, that's what I was doing at the first of this lesson. I had it typed in so that we could do this quick. So our standard, this is our mean, right? Isn't this average? 66.1, and our standard deviations was 2.9. So I'm going to write that down. So our average, our x bar, was 66.1, and our standard deviations were 2.9, wasn't it? Okay, sweet. So let's look. I have my data set in order from least to greatest. Well, no, I don't, but I need it to be. I need it to be. So let's quickly do that really quick here. So let's put this in order from least to greatest. So it'd be 62, 63, 64, 64, 65, 66, 68, 68, 69, 72. Okay, good. So now look, our mean is 66.1. So where would that go?
Right there.
Right here, right? So our average is 66.1. So then, one standard deviation above and below. So we're going to go one standard deviation above and below. So we're going to add our standard deviation on. So tell me, what's 66.1 plus 2.9? It's 69, right?
Yeah.
So that's one standard deviation. It's 69, right? What's one standard deviation below? So you'll take 66.1 minus 2.9. 63? 63.2. So that would be up to here, right? Not right here, because so 63.2 is within one standard deviation. So guys, the values that fall within one standard deviation would be all of these values. Aren't those the values between 69 and 63.2? Those are the values within one standard deviation. Now, so it says, determine the whole number of standard deviation that includes all the data. Don't we need to go another standard deviation to fit these? Okay, so let's add 69 plus 2.9. Let's go another standard deviation. 69 plus 2.9. 71.9? So that's two standard deviations. I would put 71.9. Does that include 72? No, so we have to go a third standard deviation to fit that in.
Yeah.
So let's go one more standard deviation, and that would put us at 3 standard deviations. We know it's going to include it, right? So let's go below to see if we're good here. So 63.2 minus another standard deviation. So 63.2 minus another 2.9. So that puts us past this, right? 2, so 61 point... You said 61.1? 3. Sweet. So didn't that include all those? So within how many standard deviations included all the data set? 3, right? Didn't it take 3 to include it all? 3 standard deviations from the mean. Because it took us 3, right? To include 72. So it says, how many items fall within 2 standard deviations? So let's count. How many fell within 2? So once again, looking here, didn't, so 2 was 61.3, so does not include these. Then all of these, and then 2 standard deviations was 71.9, so it wasn't 72, but it was 69. So wasn't that, all of them except 1 fell within 2 standard deviations. Does everybody understand? So 1, 2, 4, 5, 6, 7, 8, 9 out of 10. So you could just say 9 items fell within 2 standard deviations of the mean. And if it said what percent of the data, when you say 9 out of 10, which is 90% of the data, fell within 2 standard deviations. Does everybody understand? Okay, sweet. Do 7 through 10, 13 through 17. Make sure your stuff's in order from least to greatest. Find your standard deviations and your mean, and then work your way outward like what we did. Like what we did here. So it says, use the standard deviations to compare the data. So on number 11, we're comparing prices of 10 cars sold at Joe's in 1998. These are the prices. I've taken the liberty of putting them in order. Is everybody okay with that? Then also, the prices of the 10 cars sold at Joe out of car lot in 2008. So we're comparing these looking at the standard deviation. So you just type it into your calculator. I'm just going to give it to you because you all know how to do that. So our standard deviation is sigma, and sigma in our calculator is 176.18. So then sigma here, like I said, you have to calculate it, but I'll calculate it for you, is $2,240.70. So now we're comparing the sales at Joe's Cars from this year to this year. So let's think about it. Standard deviation means how far it deviates from the average, right? So our standard deviation is $176. So on average, you know what I mean? Our standard deviations are 176.18, where our standard deviations here are 2,240.70 from the mean. So let's think about what this means. Isn't this a much larger deviation from the mean? So maybe this year it could mean a couple things. The cars here were either all around the same type of car, right? Like we have all around the same price, roughly. Does everybody understand that? And then up here, they could have really nice cars or really low cars. That could mean that. Does everybody understand that? Because if you're deviating from the mean, you might have some car that's worth a lot. Like you have a Cadillac and a bunch of, like, whatever. Do you get what I'm saying? So what I just said is cars were more around the same price. So cars were more around the same price. Were more same price in 1998. Does that make sense of why? Because if the standard deviation is smaller here, they were all a lot closer to the average. Does everybody understand why? We're all good with using standard deviation to compare.
Yes.
Okay, sweet. So you'll finish the worksheet. Don't do number 18. So no 18. So once again, the easiest way to work through standard deviations is to just draw yourself a plot. Say, okay, so my mean's 50, one above, one below. That would be if our standard deviation was 10, then 60, 40, and continue.